guys, welcome to our webinar, Unleashing the Power of Data Analytics in AWS. My name is Sammy Anderson. I'm our marketing manager at Softcrylic. We are super excited to be able to offer this for you in partnership with AWS. We have Gandhi from there, Johnny and Nats from our side. They're gonna be going into detail about data analytics within AWS and then providing a demo in the later half of this webinar. If you have any questions throughout, throw them in the chat. We will have a poll launching and you will get a survey after the event as well. We would love if you could participate in both. We're also going to be talking about a couple offers we have around these services with AWS as well as with Softcrylic towards the end of the panel. If you have to drop off at any point, feel free to reach out to me or info@softcrylic.com to find out more of what was happening while you were out. With that, I'm going to hand it off to Nats. And you, excuse me, and you guys can enjoy the webinar.
All right, thank you very much, Sami. Welcome all. Appreciate your time joining in this webinar and to see what we got to offer. All right, so today we are going to talk about implementing real-time data pipelines using AWS. And our panel for the day is me, Nats Sivaramakrishnan, and I'm the Director of Architecture within Softcrylic. I have like about 20 plus years of experience implementing both application and data platforms, data-driven applications. And I've been associated with Softcrylic for the last 11 years, implementing a wide variety of applications. And I will be walking you guys through the deck today, and Gandhi will be co-presenting me and talking about the various AWS services that are available as of today to implement really cool real-time solutions. So with that, I'm going to hand it over to Gandhi, and he will introduce himself. Gandhi.
Yeah. Hi everyone. I'm Gandhi Raketla. I'm a senior solutions architect with AWS. I have more than 20 plus years of experience in analytics, application management, migrations, and then developing the app development. I've been at AWS for the last 3.5 years. I help the customers and partners on the migrations, and I'm also part of the AWS analytics specialty group. Today I'll be walking you through the real-time analytics streaming framework in AWS and what are the different services which we can leverage to build that real-time analytics using AWS. Okay.
Thank you, Gandhi. And now we have Johnny, who is helping us with implementing the demo, and he was the one who will be actually demoing the solution that we guys have put together for you. So Johnny, please go ahead.
I am Johnny. I am lead software engineer in Softcrylic. I have total 18 years of experience in software engineering, and I'm working for the last 7 to 8 years in AWS services building data pipeline.
Right. Fantastic. Thank you, Johnny. And yeah, we have our awesome Sami, who is the moderator for this webinar session. So thank you for putting this together, Sami. Appreciate it. Okay, so today's agenda, before we get into the details of implementing real-time analytics solution using AWS, we're going to provide an overview of Softcrylic and talk about who we are, what we do, and how we can help you guys. And it's not going to take a lot of time, just 2 minutes. Then I'm going to talk about the heart of data-driven analytics, right? So I'll be touching upon modern data solutions, the need for implementing real-time analytics, and some of the business problems that can be solved with implementing real-time analytics solutions. Then I'll hand it over to Gandhi, and he will walk us through the AWS services that could help us implementing real-time solutions. Then we will move into the demo session where we will talk about a problem statement, and we'll talk about how the environment is set up. And then we have 2 different demos for you guys. One is to collect data in real time and then do batch processing, and then using Kinesis Stream to implement real-time data processing and sending data into downstream applications that could use that information and then benefit with that data. And we will also talk about cost considerations, security considerations, and finally we'll have time for you guys for a Q&A session, and then a couple of offers that we have to discuss about how we can help you guys. So with that, let's get started with Softcrylic introduction, right? So we are a data company, right? And our motto is to make data work for businesses and deliver insights. We've been in the industry for like about 21 years now, and I have been associated with Softcrylic for about 11 years. And we are AWS consulting partners. And we have been associated with AWS right for the past, I would say 10 years, and right from their EC2 days. And we had also used a wide array of their tech stack implementing solutions for our clients. And these are the various services that we are currently offering to our clients and we have implemented as well. So we help clients migrate into AWS, and we help implement data foundations for our clients using which they can build advanced analytics or machine learning solutions on top, or use that consistent data for various downstream systems. And we also provide quality and governance services for our clients, because this is the biggest challenge that we have seen. A lot of our clients have data platforms, but the quality of data is always like a challenge for them to really use it across various different systems within the organization. So we have set up a separate practice for that. And using AWS services, we help them set up a data foundation where they can have quality data that can be further used by all downstream systems. Our approach to implementing data platforms is basically discovery, value creation, and acceleration. So as part of discovery, we conduct a workshop, understand what the problem is, and then as part of value creation, we set up that data foundation for our clients, which will actually have the quality data for any of the downstream systems to use. And then finally, as part of the acceleration, we help them set up advanced BI environments and also machine learning or data science environments with which they could actually harness insights from the data that's, that they have within the organization. These are some of our clients that we have worked with in the past and who are also currently we are working with, implementing data platforms and also data-driven applications. So now we are getting into the actual webinar. So the heart of data-driven analytics. So I'm going to touch upon like what modern data solutions are, and then the need for implementing real-time analytics, right? So we all know like this is a data-driven economy, and all businesses in this economy needs to be a data-driven business to be really successful. And modern data solutions can really help them be successful, right? And a modern data solution is a solution that provides the ability to collect data and deliver insights in real time, which is really critical for businesses to provide better customer experience. And that's what we have seen. And in our experience, we have worked with companies that do collect data, like a lot of data, terabytes, petabyte scale. However, not all companies really harness the insights out of that data, right? And this is because they have like traditional implementations that process and analyze data in a very monolithic way, meaning they would have a single ETL job or a series of ETL jobs that does data collection, then that does data validation, then data computation, and then finally pushes it into a warehouse. And when you have an ecosystem of jobs that works like this, it's really tough to get in, implement real-time solutions and modernize it, right? Because then at that point, it requires high cost investments and planning. And it generally wasn't like a viable option for a lot of businesses. And that is where like modern data platforms really come in and then help. With modern data platform implementations, like they heavily rely on cloud solutions to deliver real-time capabilities at low cost, allowing organizations of all sizes and scale to become data-driven. And that is the benefit. I mean, I particularly want to quote about AWS, the wide range of services that they have for organizations to really transform and implement real-time solutions. Like if you were to think about it, right, there's a lot more value for businesses to understand their customers using their own data rather than using market research data, which is like too broad and generic for a lot of use cases. So, and that is where like real-time analytics really helps businesses to track their audiences, customers, go back to them, and then understand their customers better and provide business value. I mean, this requires businesses to be like data-driven businesses, and a data-driven business generally means that making decisions using facts and insights and the trends. And the foundation for that is to be able to collect data in real time, delivering insights quickly, and most importantly, democratizing the data across the organization for the enterprise, the BI, and the data science teams, so that all can infer the same story across the board and generate insights. Now, the need for real-time analytics is really important for organizations because it lets them be more agile and nimble when it comes to defining their business strategies, right? At Softcrylic, we have experience working with our customers, solving these 3 different kinds of problems. This is just the top 3 that we have worked with. So we have clients who are into the e-commerce business, and we have helped them automate their order tracking solution to track their customers or follow up with their customers to convert them quickly without wasting any time. We have done this for airline industry ticketing solutions. We've also done this for e-commerce shopping experience customers. Then we have implemented real-time solutions for learning management systems, where in a classroom setup, as the students are working on their assessments or practice exercises, we sort of gather the student responses in real time, and then feed it back to the teacher in a constructive way, so that she can really understand the struggles for these students, and then work with them right there in the class to resolve some of their student issues. We've also implemented similar solutions in the ad tech space, particularly around ad operations, where when a campaign flight goes in, we really measure the placements or the images that are flighted, make sure that everything is on track. And if there's a problem, then trigger a workflow so that the ad operations team can come in and then fix it immediately. Because particularly in the media business, any time lost is revenue lost, and that is particularly true with the seasonal campaigns that are activated around the holidays. There are also other examples, applications of real-time analytics. You can use it for tracking information from IoT devices. We have used it big time in figuring out data anomalies where data is flowing through multiple different systems, and it's really beneficial. And there are other smaller use cases that we have dealt with, but at this point, these are the 3 that are worth mentioning. Now, with that, I'm going to hand it over to Gandhi, who will talk to us about the AWS services using which we can implement real-time solutions. Over to you, Gandhi.
Yeah, thanks, Nats. So firstly, we talk about the streaming real-time data with AWS, like why AWS, right? So what are the benefits or advantages you're having in AWS for real-time streaming analytics? So the fundamental thing is that one thing is what we see a lot of streaming solutions is that they are very difficult to set up, that means it requires a lot of infrastructure to set up the streaming services, the ingestion mechanism, the storage, the processing. What AWS solves the problem is it is easy to set up. And at the same time, we are able to easily achieve the high availability because these are all fully managed services by AWS. Some of them are fully serverless. So you don't really worry about making those services up and running all the time. That is taken care of by the AWS. The third challenge what we are having is error prone and complex to manage. That's where the fully managed helps us. And then what you're having currently with a lot of services is that big challenge. A lot of customers are scaling them, right? Because you don't know how, when the demands are going up and the demand is going down, you need to scale up and scale down. It involves a lot of effort. what this problem solves is AWS solves this problem by an easy to scale solution. And third aspect is, once you have the streaming data coming to your system, like you're getting some clickstream data or IoT data, you should be able to integrate that with a lot of other services, right? If you want to integrate with some other service, like you want to integrate with S3 or with some DynamoDB or some other solutions, it requires a lot of development. But whereas with AWS, you have a seamless integration with a lot of AWS services. Streaming data can be put into S3, it can go to an object storage like S3, it can go to a data warehouse solutions like Redshift, or it can go to some log analytics like a Splunk, or if you want to do some Elasticsearch, you can direct the data to Elasticsearch, and you can, that is all seamless. And then, not as far as the cost is concerned, it's all like, since serverless model, AWS model, it's all pay of what use model. So having said this, with this background, like, what the cloud AWS platform offers an advantage for real-time streaming analytics, let's look at the broader framework of streaming analytics, right? So if you see entire streaming story, it involves 5 different stages. One is that we'll revisit this slide again, but I'll talk about high level, but again, I'll go detailed in depth of each one of them coming slides. The first one is source. Then we talk about what are the different sources. Then we talk about the streaming ingestion mechanism. We talk about streaming storage, the stream processing, and destination. Yeah, please go to next slide. Yeah, now we'll talk about the source. So what is the source? These are the sources that generate streaming data. This could be somebody web click stream. That means anybody time clicking on any web clicks, you are capturing them as some kind of a JSON data, or it could be some mobile apps, or it could be some IoT sensor, some industrial sensor, like they're capturing your humidity, temperature, or it could be some sensor near a toll booth, which is continuously monitoring the traffic, or it could be some metering records, or it could be in application logs. You're running some application that generating continuous logs, and you want to continuously monitor those logs to see any anomalies you find in the logs and take an action immediately. So these are all the different sources. That means the streaming sources are sources that will generate the data continuously at a high scale. Okay. So once we identify the streaming sources, the next mechanism is how do we ingest them, right? Now, the source, the IoT sensor is generating some sensor data, clickstream application generating some clicks data generating. How do we ingest that? This is where the streaming ingestion comes into picture. So to ingest the streaming mechanism, we have got multiple ways. So one is that there are some AWS toolkits and libraries, some service integration, some third-party offerings. If you look at that, we're having something called AWS SDK, which provides you where you can use that SDK to ingest the data into AWS streams, like Kinesis streams. Or we have got Kinesis producer library, also called KPL. It provides you all the batching aggregation mechanisms, where if you're having, instead of you sending each record one by one, you can actually batch them, group them, aggregate them, and send them. Or we have something called Kinesis agent. What agent is that? You might having some application logs, right? So the application logs are being continuously generated. Instead of you manually doing, if you install Kinesis agent, the agent can actually automatically ingest all the logs coming out of this application logs into the Kinesis streams. Apart from that, we also have the services like AWS IoT service, like for you have an IoT devices, or you're having CloudWatch logs, you're getting the logs in the CloudWatch and you want to ingest them into a stream. Or you might, another thing is that you also have AWS database migration service, also called DMS, where you are actually migrating, doing some kind of a CDC from the on-premise databases to the AWS. And every time some change happens, you want to stream the change to Kinesis stream, we can use that. Apart from that, we're also having something like Log4j, Flume, Fluented, all these third-party services, which will help us to ingest the data. So once we have the source, we have the streaming mechanism. We know how to stream it. We identified a source, we identified how to stream it. The next step could be, how do we store this data? Like the data has been ingested, but how do we store the data, right? This is called stream storage. This is where we are having Kinesis data streams. Basically, Kinesis data streams is a one which will actually hold the data. That means that's where you actually ingest the data. Again, these are all fully managed. Is it easy administration and low cost? It is real time. It can scale up and scale down. And then it is a secure, durable storage. By default, you can store the data for 7 days, or maybe you can extend the data from 8 to 365 days also, depending upon your requirements. The good thing is, once the data is in stream, you can have multiple applications can actually take the data and process it, right? This is where a Kinesis data stream helps. Yeah, we move on to the next slide. So next comes is one of the most important thing, right? Like, how do we process the data? This is where you require to be like multiple services, all the scaling mechanism, everything comes into picture, because you have the source, you have the way to ingest the data, you are able to ingest the data, but now what do you do with that? How do you process it at scale, with performance? That's where in the AWS, what we have got something called Kinesis Data Analytics. This is basically you doing analytics in real time on the streaming data. Just take an example. You are having some industrial IoT sensors. You are continuously capturing something like a temperature, humidity. You are capturing a lot of parameters, and you want to make sure that anytime, at any point of time, the streaming data, the temperature goes about certain value, you need to raise an alert to some administrator or send a message to somebody, or maybe just flash it on some real-time dashboard, which is continuously showing this data from the sensors, right? Or maybe you are monitoring a toll gate where you are continuously monitoring the vehicle traffic, and you suddenly want to see that there's a dip in the traffic for a few amount of time. You want to know whether some accident happened there, something is not working, what is going on, right? That's where the Kinesis data analytics help you to do analytics in real time on the streaming data. Now you've got two options to do this. One is through SQL. That means you can write a SQL queries, which would actually read the streaming data and then give the result, or you can use something like a Flink, which is a Java-based application, Apache Flink, a Java-based application to do that. So either you can write some Java code or SQL. Apart from that, you are also having Kinesis client library, which will provide you a rich set of functions to do all the load balancing, or apply any sort of something like you want doing some kind of aggregation and all the things you want to apply. You can use KCL. Apart from that, you are having AWS services like Lambda, which is serverless service, where all you do is event-based mechanism. Anytime a record lands up in the Kinesis stream, you have the Lambda, which will invoke and then process the data. Or you can use Amazon EMR, like you are getting huge millions of records. You want to use Amazon EMR. So we can use Amazon EMR for services. Apart from that, we are having a lot of third-party services like Spark. You're having Datadog, Apache Storm. All these third-party services will help you to take this data and then process it and then produce a result, have the real-time analytics be done. So, yeah. Again, we talked about Kinesis data analytics in the previous slide. So how the Kinesis data analytics works is you connect to a streaming source. That means you connect your stream, like your ingest data to Kinesis stream, like as I told, any IoT sensor data, web claims, you connect a streaming source. Then on the streaming source, as our data is coming, you write a SQL code, a Java code to process streaming data. And then you can output the results to say some S3 bucket, or you can send it to some Kinesis file host. From there, it can actually go to the another database like Redshift, or or you can write some custom code to put this data into some DynamoDB. So you can, depending upon your data source of choice, you can actually deliver the data to them, or you just want to send some alert, or you want somebody to see in QuickSet dashboard something something is going on here. Yeah, please go to the next slide. So the next part comes the destination, right? So now we gone through the source, ingestion, storage, processing. Now, how do we send this data? Do we have any mechanism to send this data to the different destinations? This is where we have got something called Kinesis Data Firehouse. Kinesis Data Firehouse is again a fully managed service wherein all you should do is, yeah, this is my streaming data. Anytime the data comes to this one, I want to send this to S3, or I want to send it to Redshift or Elasticsearch or Splunk. take some clickstream data, continuously getting clickstream data. All you want to do is, as and when the data comes, you want to have Kinesis Firehouse to be there. Kinesis Firehouse delivered to S3, and then from S3 you can run the glue crawlers and have some service like Athena to query the service, or you could generate a dashboard from QuickSight once the data lands in S3, or you could send it to Redshift, or it could be, if it is some kind of a logs you're getting continuously, you can also send that logs there to Splunk, where you can do a log analytics on that continuous stream of logs. Yeah, so this is where we call, like, we have, if you put together all together on ingest side, where you've got Kinesis agent, which just ingest the logs from your source, or you're having Kinesis streams, which is actually what actually store the streaming data. We're having Kinesis CloudWatch logs, which can actually also ingest the data. And then we could have CloudWatch events, IoT, even if you have Apache Kafka kind of stream, can ingest the data into the Firehouse. Once the data is ingested in Firehouse, you can also apply some transform. For example, you want to convert the data is coming in JSON format. You want to convert into, say, Apache Parquet or ORC format, or you want to do some kind of a processing on the data as and when the data is coming before ingesting. So that's where you use Lambda. So you can write some custom code in Lambda to process the data in real time, or you can actually simply say, okay, I want to convert this data into JSON to Parquet. It will do automatically. And then next one is delivering, right? That's where you deliver it to S3 or Splunk or Redshift. So putting it all together, this is where what we're having: the sources, mobile devices, metering, clickstream, sensors, and then we are having some streaming ingestion mechanism using agents or Kinesis library or SDK. And then we perform real-time analytics using either Kinesis Data Analytics or Kinesis Consumer Library. And then we can also send this data to multiple destinations using Data Firehouse. See, again, just one important point here. We can see that destinations means it need not be S3, Redshift, and Splunk, only 4, but default what Firehouse does. But if you are having a different destination altogether, like you want to put the data on DynamoDB or to some RDS, Postgres or Aurora, you can write that's where you can leverage Kinesis Consumer Library, which can do the job for you. Yeah, this is what an end-to-end perspective of the streaming architecture on AWS, starting from source to ingestion to storage to processing to destination.
All right. Thank you very much, Gandhi. Appreciate your time. Cool. So now is that we have an idea about the type of services that are available in AWS to implement real-time solutions, let's look into a demo, right? So Johnny, I think you're ready, but let me set the context here for our audience. So we'll talk about the problem statement first. So assuming that this example, what we're seeing here is one of the examples that Gandhi talked about earlier, right? So how do we analyze clickstream data? This is basically to figure out like, okay, users are coming into my site and I want to know what they are doing and I want to know it real time, right? That's the use case that we're looking at right now. And this also could be like extrapolated for other scenarios that I talked about earlier around order tracking or student utilization and whatnot. But for the purposes of this demo, we just wanted to keep it simple. And so we're just going to track some of the user activities in the web page so that we can decide what we want to do or decide how we want to change the content within this website, correct? Now, what have we done? So there are two streams of work that we're doing, right? So one is we are collecting this user information. We are using Kinesis Firehouse, and then we are pushing it into S3 bucket. That is one stream. The second stream is we are collecting the data using Kinesis Stream. Then we are processing that data real time, and then we are pushing it into DynamoDB, and then we are showing real-time reports to the users. There are two work streams, and both these work streams use these technology sets, right? And that's what we are talking about. So the first thing is like there's a client application, which is a HTML application, which will constantly keep posting messages to a web server. And we have set up like an elastic beanstalk where we will run Node.js applications that will collect that information. And the reason why we set it up is for security reasons and security best practices, which we have been following in enterprises to avoid unnecessary attacks to our environments, or to restrict the sizes, or to restrict the access by apps and all that stuff. From the client application, you can also directly post messages to Kinesis, but that's not what we do in our implementations. And this also allows to scale and then gather more information if we need to, and manage some failovers. Then the information that's collected by this endpoint that is hosted in Elastic Beanstalk will push the data into Kinesis Firehose. And what we have done is, like, we have set up a maximum buffer size of 1 MB. Or we have set up the intervals to actually 5 minutes is wrong. It's actually 1 minute. So what it means is that every 1 minute, it will keep creating a new file and then drop it into an S3 bucket. Or within that 1 minute, if the file size reaches up to 1 MB, then it'll immediately create a file and then drop it into Kinesis, into S3 bucket. The reason why we are doing this is because, as part of the best practices approach, whenever you implement a real-time solution, it is important to keep your file chunks smaller, because the downstream applications that will have to process all this data cannot be overloaded with large volumes of data. If you keep it in smaller chunks, it will process it much faster. And particularly when you have to scale, it is absolutely important. So that this way you can have you can process 10 or hundreds of files parallelly using the serverless architecture that's available in Amazon. And so this is, again, one of the best practices that we follow as part of implementing real-time solutions. Then we also used Lambda functions, right? So Lambda functions are used to standardize the data. So each of these web applications, right? Let's say that you're collecting data from 10 different web applications, and they might be sending data that is particular to that application into this Kinesis stream. Now, we may want only certain attributes out of that data and not all the data. So this Lambda functions will help standardize all the data points that are being posted into the Kinesis stream. So this way we don't have to, in real time, so this way we don't have to do like data formatting, ETL, we don't have to implement data formatting ETL pipelines downstream, and it makes it much faster. And one thing that you need to ensure is that when you're using serverless architecture and using Lambda functions, make sure that your code does not run more than 15 minutes. Otherwise, it'll stop, and because that's the max limit for Lambda function executions. And then finally, we are moving the data into S3, where we are ensuring that the data is encrypted at rest for security measures, lifecycle policies. But the common thing that we have seen in our customer implementations is that because S3 is cheap, they have the tendency to dump it with so many files. And eventually what happens is, like, the size grows massive and the customers end up paying more money down the line. So whenever we set up S3 buckets, as part of the best practices, we ensure that the lifecycle policy is set up so that the cost is maintained at an optimal level when managing all this data. And you also need to ensure that, if you're sending any PII data, which is personally identifiable information that's passed through your Kinesis pipeline, it is all properly encrypted for data security reasons, right? And also set up appropriate API keys within your S3 bucket so that only the Kinesis stream can access it. Or you can also use IAM roles and permissions to enable access between Kinesis and S3 buckets. So as I said earlier, you have Kinesis Firehose approach, and also you have the Kinesis stream approach. When to use what, right, is the biggest question. And when you don't have any downstream applications that needs to consume these messages and do their own processing, use Firehose, right? Because when you use Firehose, it's much easier to push the data into S3 bucket or into Redshift or any of the downstream storage locations at scale, and you don't have to implement custom logic to implement such solutions. So in this example, what we're going to do is that as and when the user clicks and then goes through the web page, all that information is posted into the website, and then from the web page to the web server, which collects all that information and then pushes into Firehose. And Firehose will process that data. Lambda functions are integrated to it, and every 1 minute it'll keep pushing, generate a new file, and then push it into S3 bucket. Now, what we do, integrate like client-side JavaScript, which we call like a data layer, which will be pushed from the server to the client application, which can basically gather any information from the website and then push it into the web server, right? So Johnny, do you want to share your screen now and then show us like how you have implemented this example?
Sure. Can you see my screen?
Yes.
Okay.
So this is the web page, guys, that we implemented. If you look at it, it has a lot of links, and users are able to perform various different actions. And as and when the user clicks on a link or something, we have opened the developer tools within the browser here. You will notice that it is posting information back to the server. Now, Johnny did a page refresh in here. So as the initial page load happened, it did post a message to the web server from which information will be pushed to Kinesis. Johnny, can you also click on, perform a search action. All right, again, so in this case, it is again posting information back to the server. And in this case, can you scroll down, Johnny? Can you open that payload? All right, so here we are keeping it simple, right? So we are just sending a unique ID, and then we are sending a request type. So we're just tracking the clickstream data, what the user is doing. And you can obviously add more details to this and color to it, right? Cool. So can you go into the AWS environment and then show the Kinesis Firehose setup and the Lambda function associated to it to transform the data? Thank you. So if you look at it, this is the Kinesis Firehose setup, where you go in and then configure what this needs to do and in what S3 bucket the data needs to be pushed into, and what the buffer size is and all that. And again, configuring a Kinesis Firehose is extremely simple. So this is the buffer limit that I talked about earlier, where you have 1 MB size. You can restrict your file size to 1 MB or 60 seconds buffer interval, so that whichever is earlier, it will create a file accordingly and then push the data to keep the file sizes optimal for downstream workflows to process the information. The other benefit of using Kinesis Firehose is like it also provides like out-of-the-box compression and encryption capabilities. So if you need to compress your data because of the size, or if you need to encrypt the data, you can certainly do it. So Johnny, can you show the Lambda transformation associated to this? Yeah.
Sure. So the code we cannot see in console because it's big, but I have open here.
Sure, thank you. So this is the Lambda function, which basically traps or captures that message and then transforms it and then pushes it into, back into the stream so that it can be pushed out to the S3 bucket. So basically you will have access to the events that are being posted into the Firehose. You can capture message by message or by file and then process the data. Johnny, can you open the file in the S3 bucket that basically got created based on the clicks that you did? I think you stopped sharing your screen.
Oh, let me share. Can you see it, Max?
Yes, now I do.
Okay, so this 18th folder is just created. You can see the timestamp, 39th minute.
Yeah, so this is all information that we clicked in that web page that was tracked in Kinesis, and then it got pushed into this S3 bucket. Now, again, as I said earlier, this is a scenario where we don't have any applications that are looking for these messages to do their own processing. This is purely to do let's say reporting, a company org-wide reporting that you would have to do across all the information that you collected, and refresh that report every 5 minutes, right? So in that use case, you can certainly use this. And this is what Johnny did. So he sort of captured all that information across various different activities, and then he is uh, pushing the information into S3 bucket. And now he's flattened all this information. This information can be picked up and then be processed or pushed into other downstream data stores for further analytics that we'll have to do. All right, so now let's move on to the next demo. So in this next demo, what we are going to do is, like, let's say that we have a real-time dashboard, a downstream application that needs to gather this information and needs to do its own process, right? So our downstream application in this case is like a real-time dashboard, where as and when the user clicks, let's say I wanted to know, let's say you have like a gaming website, right? And you want to know like how many users are online. So as and when the page loads, you want to go to a place and then see the user count, and then make decisions accordingly, either like block new registrations once you hit your peak capacity and whatnot. So this is like a very similar example. So users will be clicking around, but then there's another page that will keep refreshing, as and when the user data is updated. So this is that simple dashboard that we created, right? So when Johnny, let's say he hits a refresh in this page, you will see this number go up to 40 immediately, right? See, the number got updated in there. So similarly, if he goes and then clicks a button or does a search, then immediately you will see that search went up from 19 to 20. Or when he does some action, the numbers will change. So this is very helpful when the action triggered from your web application will become data for other downstream applications, which will have to do their own thing, right? I mean, if you were to look at a traditional system, what generally we will do is, like, all the information that's collected will be first housed into a first-party data store that's specific to that application. And then we will write ETL jobs that will take that information and then push it to other applications, correct? Or what we'll have to do is, like, write more code and intelligence into the application in itself, which will then have to push all that data by calling APIs to third-party downstream applications. And all these processes are cumbersome. This will really help you push data into a single source. And from there, any application that has registered for that event can easily connect and then extract the information. All right, so EMR use cases, right? I will come to that in just a bit because we just only have a couple of more slides. And once it's done, I can jump into that question. So thanks, Johnny. I will now take over and then share my screen. All right, I hope you guys are able to see my screen. So this is the use case number 2 that Johnny just demoed us. Again, from a web application, the data is being posted to the web server. From there, it's being sent into Kinesis Stream. And then our Lambda function transforms it real time. And the data is pushed into a DynamoDB. And the dashboard reads information from the DynamoDB and then displays it in the web page real time as things happened. Now, some of the considerations that you want to take into account, right? So whenever you implement real-time solutions, you need to consider your data stream size, right? So it is absolutely important. You don't want like a big, huge chunk of data that's being sent from the client to the server, and that will both impact you from the infrastructure cost and also from the performance. So you need to find the right optimal size, and that should be a huge consideration for you. Then similarly, the jobs that are taking, the Lambda functions that are taking that information and then processing it, you need to be careful about how much data you process or how complex of logic that you're implementing in those Lambda functions. Because as you are processing real-time information, you want everything to happen in sub-second response times. And if you have a logic that takes about few seconds, then that is again going to impact your end result of implementing a real-time solution. And if you have to have complex processes implemented, and that is where EMR comes into play, I'll talk about it in just a bit, but you need to be extremely mindful about the data size. That's critical. Similarly, the data storage. When you set up your end data storage, like, again, you need to make sure that you have your recycle policies set up appropriately. You don't have large volumes of data sitting in there. You need to set up appropriate folder structures so that you are easily able to navigate through and then find the files, and all that needs to be considered. Then processing cost. How many messages are going to be streamed into your environment, and how many Lambda functions are going to be executed concurrently, and what needs to be the scalability set up. So you need to take all that into account. That is going to influence heavily into your overall infrastructure cost. And then finally, the amount of data that's being transferred between the environments. You can definitely use Amazon's pricing calculator. That will provide more information and be very helpful whenever that you're putting a system together like this. Then some of the security considerations that you need to take into account are encrypting data at rest and also in transit. That's absolutely important. You should also follow least privilege access model. So that means like your Kinesis stream needs to be appropriately secured, and also your S3 bucket needs to be appropriately secured. The typical best practice is to use IAM roles to do that, or if not, they also provide API keys, but ensure that the keys are secured properly in your key store or key vault so that it's not accessible to others. I mean, we have seen so many examples wherein developers store their keys in their source code, and then that source code is checked into a public Git repository. It definitely is not a good scenario if that happens, gets into the wrong hands. Then data compliance standards. If you are using any PII data, or you need to adhere to any sort of like GDPR, CPPA compliance, you need to pay very close attention because you don't want all that sensitive information hanging around in your Kinesis stream, because if you have a downstream applications that's consuming that data, then it'll become tricky. You either need to encrypt it, or not even best thing to do is to not even send that data into your stream. Then setting up like appropriate network security just to ensure that there's a sufficient threat detection setup, and also set up alerts. Amazon does a great job in there are two ways of security that works with Amazon, right? In my experience, we as an architect, you can go in, or a developer go in and then set up your own alerts and security and monitor your infrastructure. But Amazon also has their own artificial intelligence enabled monitoring solutions that are in place, which can, they monitor it and then they send you notifications. And this has happened in my early stages when I had made a mistake of not securing my environment properly. Amazon is the one that captured that and then sent me the details where I could go and then fix it. But paying very closer attention to that is important. Yeah, so this is something that I talked about, right? Making sure that you have your appropriate keys, and keys are stored in key vaults and all that. Tracking what happens in your environment is really critical, right? And to that end, you can use cloud trial servers in Amazon that will monitor all these things. So if in case you need to go back and then audit any of the information, this will certainly help you. I mean, obviously that's not going to have, there's going to be a cost to that because it's logs, and the depth of the information that you have in those logs is definitely going to impact. So you need to balance that and then figure out how you want to manage it. All right, now that brings us to the Q&A section. So Sammy, are there any other questions apart from the one that popped up in my screen? Or oh, sorry guys, 1 second.
I don't see one, I don't think.
There was a chat message that I saw about EMR.
I don't see any in the Q&A, so just the chat.
Ah, okay. Where is the chat?
Actually, I replied to that message, but I think
Okay, so you want to take that, Gandhi?
no, actually, I replied to the message, but it looks like I posted only to the panelists, not to everyone. Maybe let me the message to everyone.
So, I mean, there are two types of analytics solutions that we have implemented, right? One, I would like to call it as like data lake analytics. And then the other one is, warehousing analytics. With data lake analytics, what we generally do is, you have your data stored in S3 buckets, and then you compute and process everything using scripts, and then finally push the processed data into your final data store, which can then become the single source of truth for all the downstream systems, reporting systems, applications, and everything. So in that scenario, we definitely use EMR. And the first solution that we showed you guys in here, right, where the data being collected using Kinesis Firehose and then being pushed into an S3 bucket, we have an extended version of that, which we have implemented for TWG, the weather channel, right, where but then that data is like in large scale. So we have EMR clusters rolled up, and then we have three different steps that we need to implement called like sessionization, aggregation, summarization, and all that stuff. So where we will break down the data by various different user sessions, aggregate it, and then roll up based on the business requirements and then push it out. Now in that use case, what we have done is that we have set up EMR clusters. Which will then take this information out of the S3 bucket, process that, and we are using Spark scripts to do that, and then finally push it into the Redshift data store. Johnny, would you like to add any further color into that? Or I think, did I explain that correctly?
I think you already explained that.
All right, thank you. So EMR use case, EMR, so whenever it comes to serverless architecture, I always tend to separate out the processes that we would have to do because it makes it more efficient and also more scalable. So with this real-time solution, any real-time implementation, the data collection piece needs to be its own isolated piece. Then the data processing piece needs to be its own piece, and then the data delivery needs to be its own piece. So to that end, our EMR implementations generally start from the location where the files are being dropped by Kinesis. Our EMR solutions directly don't connect to Kinesis environment and then extract the information out. The reason why we want to do this is because retaining data in Kinesis environment is going to cost you money. I mean, particularly in a high-scale, high-volume transactional environment, if you have to retain data 7 days or for more than 7 days, it's an issue. That's one. I mean, your cost will be exponentially high compared to having that data in S3. The second thing is like you also want to be able to replay that data. So let's say, for instance, you decide to store your data in Kinesis stream only for 7 days. And then, if you have directly integrated your EMR solution into Kinesis, then if you have to replay it, right, you cannot. And you have to do separate implementations to get that data again from S3 and then to replay that data. But let's say, for instance, you need to replay all these events from a month ahead, a month prior, because something went wrong, then your entire workflow is already in place. All you need to do is like change your parameters that will, instead of getting the data just for the last hour or last 5 minutes, will just bring the data for last 1 month and then process it in sequence and then replay the data and then repopulate your information. So that is the benefit that you get out of it. Gandhi, would you like to add any more information to what I just explained?
No, I think you pretty much explained.
Perfect. Awesome. Any other questions, guys?
I think there is one question from Victor from Kinesis Analytics. From what I can understand, we can run Lambda. Actually, Lambda, KD has got only two options. One is a Flink-based application using Java and a SQL-based. If you want to use Lambda, then you can use Kinesis SDK, and then so anytime the data lands in Kinesis stream, you can actually use Lambda functions to read the data from the stream and then do perform any analytics on it. but KDA as such supports only Flink or SQL.
Okay, so there's also a question like, how do we ensure that we provision enough Lambda functionality to process everything in real time? So when you say Lambda functionality, do you mean capacity for processing Lambda, or the amount of scripts that you would have to write within Lambda, or the extent of the script? I'm assuming that it's infrastructure. One thing with Lambda is like it is serverless, so it can scale as much as it wants. And if you appropriately break your processing logic, then you should not have any issues per se.
Yeah, and just to add to that, Nats, maybe for the Lambda, if you want to have the computing, your compute you get for Lambda functions depending upon how much memory you're allocating.
Yes.
So depending upon that, you will have the corresponding computing power is allocated. So if you want to have, if you think that it is going to take a lot of computing power, a lot of time, increase your memory allocate for the Lambda function.
Yes. And I for one generally don't recommend doing a lot of computation within the real-time data collection pipeline, right? The more complex you make it, as I said earlier, the more resources you need, the more delayed it's going to be, and the more expensive it's going to be. So you need to figure out, whenever I go in, right, for real-time, customers want a lot of things, but then they don't have enough budget. So I generally try to figure out the use cases that are primarily the business drivers for them, right? And then I reduce it to like top 3 use cases. And then for those use cases, I use the Kinesis Stream solution to give them the real-time data. But the rest of the solutions, I generally, push it through Kinesis Firehose and then process it through EMR, and then get that out in reporting, which is more sort of like a semi-real-time reporting, but then they still get the same effect within 5 minutes or 10 minutes after the data is generated, because the amount of complex calculations that are involved in generating your final output will directly impact your cost, your performance, and the time at which data is available to your client. So you need to really balance that out efficiently. And I do agree with Gandhi, you can decide that. But Johnny, I'm curious, like, what is the size of the Lambda resource that you have set up for TWG implementation?
I have to check that, Nats, but I think we have to keep the buffer size also small in Kinesis Firehose, so that the input which Lambda gets will be a smaller payload. Perfect. If it's big, again, it will take more time to execute.
All right, cool. I hope I answered your question, Victor. Are there any other questions, guys? Feel free. No question is, small question. I had been through this. I had asked a lot of questions, silly questions to AWS and to also moderators in so many webinars. It's just a platform to really get in and understand. All right, cool. So if we don't have any further questions, I'm going to move on to the next slides. And with that, we can real quickly wrap. So at Softcrylic, we are currently running a promotion where customers who are trying to get into implementing real-time analytics, we come in, we analyze the environment, and we help them implement it for like $10,000. And we are also partnering with AWS on this. So as we will also get the required support from AWS in terms of both infrastructure and also the technical support. Now, this is a 3-week startup pack. Week 1, we will come in, we will understand your business, we will identify the use cases, and we will nail the scope definition, and then we will set up the environment in AWS to actually get the work started. Week 2, we will actually implement the solution, a real-time solution to gather all this data. And week 3, we will be able to give you guys some basic level reporting that meets your business use cases and solves a particular problem, right? It's not a POC, it's not a random POC. And like I said earlier, we will work with you guys, nail down like a couple of key business drivers, use cases, and then we will implement a solution around that. So even this demo that we put together, Johnny was able to put it together in like 2 days. Correct me if I'm wrong, Johnny, I don't want to speak for you, but
That's true.
it is a fairly straightforward and easy implementing real-time analytics solution in AWS. So that's what we have. Over to you, Sami.
What was the question, Nats? I'm sorry.
Oh, I just wrapped up. So.
Oh, we're all done. If that's the end of the webinar, that's the end, or we can move on to whatever your next part is.
All right, cool. So then, thanks a lot, guys. I was originally hoping to get this done in 1.5 hours. Sorry about that, but I think we were able to finish it in an hour. And so that gives you guys 30 minutes back. And I really appreciate you all taking time and then joining us on this webinar. And I hope it was useful for you guys. And Sami will share a survey link and send a follow-up email. And I also think she launched a survey in this meeting. So we really would appreciate if you guys can provide us feedback about how relevant this information was for you guys, the amount of information that we were able to give you, and how we actually did presenting all this information to you. And we'll totally appreciate any feedback, right? Thank you very much for joining us. Have a good day.